Okay, so we're talking about axis of symmetry, or axes in this case since they're plural, axes of symmetry of quadratics. So we've got three quadratic functions. We've got one in vertex form, one in standard form, and actually two in standard form. And we're asked to find the axis of symmetry, but what exactly is the axis of symmetry? Well, parabolas are symmetric with respect to a line. That means that we can take a parabola and we can actually fold it in half. And when we do that, that line that we folded along is called the axis of symmetry. And it is found by finding the x-coordinate of the vertex. So if we are in vertex form, it's simply the h. Okay, so it's simply the h. All right, but if we're not in vertex form, if we're in standard form, we take opposite b and divide it by 2a, and that'll give us the line for the axis of symmetry. All right, so it's not much more after that than to find the vertex, but we're only going to focus here in these examples, on the axis of symmetry. So let's take a look here. This one is really easy. So if this is in vertex form, to say the axis of symmetry, all we have to do is find out, well, what is h? So in this case, since it's in vertex form, we're going to say x equals h, which is the opposite of whatever's inside the parentheses, so positive 4. So right here, the axis of symmetry is x equals 4. All right, but notice this one right here is not in vertex form, and neither is this one. But notice we're not going to have to, complete the square and try to get it into vertex form. That would be too much work. Not when we have this shortcut. And if you notice, this is the left-hand side of the quadratic formula, the opposite b over 2a. And so what we're going to do to find the axis of symmetry here is say, okay, well, if x equals opposite b over 2a, then let's list what a and b are. So a is 1, b is 0, and in this case c is 5, but we don't need c. So we're going to say opposite b. Well, what is that? What is b? It's just 0. Opposite of 0 is still 0. There's no way to take the opposite of it, really. And then we're going to divide it by 2 times 1, which is 0 divided by 2, which is 0. So the axis of symmetry here is x equals 0. All right, and if you notice, this is just a parabola shifted up 5 units. So it would not change from its parent function f of x equals x squared, which also has x equals 0 as its axis of symmetry. All right, now let's take a look at the very last example here. All right, again, this one is in standard form once more. So what we're going to do is we're going to say, okay, well, a equal 1, b equal negative 10, and c equal 28. Again, we don't need c, we just need a and b. But I'm just writing it to remain consistent. So opposite b over 2a, well, opposite of negative 10 divided by 2 times 1. So opposite of negative 10 is positive 10 divided by 2 times 1, which is 2, which is 5. So the axis of symmetry here is x equals 5. And notice that for a parabola, the axis of symmetry will be a vertical line. All right? So x equals 5 is the axis of symmetry for this quadratic here. And we've got a nice set of examples now going here for what exactly an axis of symmetry is. And in a future video, we'll take a look at how to come up with the vertex, but it's really not much more after this. To find the vertex, you're just missing the y-coordinate, but what you do is you take the 4 and you plug it in here into the original function. You take the 0, plug it into the original function. Take the 5 and plug it into the original function. And that'll give you the y-coordinate for the vertex, since we've already got the x-coordinate.